Today we are going to start dilations, which is a similarity transformation. As we know, a transformation is an operation that moves or changes the size of a geometric figure in some way to produce a new figure. The pre-image is the original figure, and the image is the new figure. A dilation is a transformation that produces an image that is the same shape as the original, but is not the same size. Therefore, a dilation is similar to its original figure. So far, we've been working with congruence transformations, such as translations, reflections, and rotations, where the pre-image and the image were congruent to each other. Here, with dilations, the pre-image and the image are similar to one another. Dilations are centered around the origin, unless otherwise stated. The scale factor is a ratio between the image length and the pre-image length. An enlargement is a dilation where the scale factor is greater than 1 and the figure becomes larger. A reduction is a dilation where the scale factor is between 0 and 1 and the figure becomes smaller. The general rule for a dilation is x, y arrow, k times x, k times y, where k represents the scale factor for the dilation. In example 1, for a, if the scale factor is 3, how would we write the rule? So just like any other rule we've been writing, we always have to start with x, y, and an arrow. Here, because our scale factor is 3, we're going to have 3 times x, 3 times y. For b, if the scale factor is 1/4, how would we write the rule? Same thing, we're going to start with x, y, arrow, and here because our scale factor is 1/4, we're just going to have 1/4 x, 1/4 y. For example 2, if the scale factor is 5/2, how would you write the general rule? And is this an enlargement or a reduction? Please pause the video and try example 2 on your own. Because our scale factor is 5/2, we're going to have x, y arrow, 5/2 x, 5/2 y for our general rule. And because 5/2 is equal to 2.5, which is greater than 1, we will have an enlargement here. For example 3, we have triangle ABC has vertices A 0, 2, B 4, 4, and C -1, 4. What are the vertices of its image with a scale factor of 4? So because our scale factor is 4, we're going to follow the rule x, y arrow, 4x, 4y. So what we're going to do to each of our vertices in the pre-image, we're going to multiply both the x and y coordinate by 4 to find the coordinates of our image. So for A prime, we're going to have 4 times 0, which is 0, and 4 times 2, which is 8. For B prime, we're going to have 4 times 4, which is 16, and 4 times 4 again, which is also 16. And for C prime, we are going to have -1 times 4, which is -4, and 4 times 4, which is 16. For example 4, we have quadrilateral PQRS with vertices P -2, 4, Q 4, 4, R 4, -2, and S -4, 4. It is dilated by a scale factor of 1/2. A, what are the coordinates of the image? Graph both of them. So here we are going to first graph the coordinates of the pre-image. So we have -2, 4, 4, 4, 4, negative 2, and negative 4, negative 4. And connect our points. So for P, we have negative 2, 4, Q, 4, 4, R, 4, negative 2, and S, negative 4, negative 4. To find the coordinates of our image, we are going to apply the rule x comma y, arrow 1/2 x comma 1/2 y. So we are just multiplying our x and y coordinates in the pre-image by 1/2. So we have negative 2 times 1/2 is negative 1, and 4 times 1/2 is 2. For Q prime, we have 4 times 1/2 is 2, and 4 times 1/2 is 2 again. For R prime, we have 4 times 1/2 is 2, and negative 2 times 1/2 is negative 1. And for S prime, we have negative 4 times 1/2 is negative 2, and negative 4 times 1/2 is negative 2 again. Now that we have the coordinates of our image, we can plot them on the coordinate plane. So we have negative 1, 2 for P prime, 2, 2 for Q prime, 2, negative 1 for R prime, and negative 2, negative 2 for S prime. So for part B, we want to demonstrate or show that these quadrilaterals are similar by comparing the ratios of the lengths. So the ratios of the lengths of the pre-image and the image should reflect our scale factor. So if we take a look at PQ, because we have a horizontal line on the coordinate plane, we can just count to find the length. 1, 2, 3, 4, 5, 6 units. Same thing for P prime, Q prime. The length, we can just count it on the coordinate plane because it's a horizontal line, and we get 3 units. Notice that the length of the image is half the length of the pre-image, which reflects our scale factor. So we can say that those lengths, side lengths for that part of the quadrilateral are similar. The length of QR, we can also count because it's vertical. We get 6 units again. And the length of Q prime, R prime is 3 units. Again, the ratio between the length of the image and the length of the pre-image reflects the scale factor of 1/2. To find the length of PS, P prime, S prime, SR, and S prime, R prime, we have to use the distance formula between two coordinate points. If you recall, the distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. So for P times S, we have the square root of negative 4 minus 4 squared plus negative 4 minus negative 2 squared. This simplifies to the square root of 68, which simplifies further to 2 times the square root of 17. For the length of P prime, S prime, we have the square root of negative 2 minus 2 squared plus negative 2 minus negative 1 squared, which is equal to the square root of 17. Again, we can see that the length of the image is half the length of the pre-image, which reflects our scale factor. Last but not least, we have the length of SR. It's the square root of negative 4 minus negative 2 squared plus negative 4 minus 4 squared. which is equal to the square root of 68, and simplifies again to 2 times the square root of 17. And lastly, we have the length of s prime r prime, negative 2 minus negative 1 squared plus negative 2 minus 2 squared, which simplifies to the square root of 17. Again, we can see that the length of our image, the square root of 17, is half the length of our pre-image, 2 times the square root of 17, which is the same proportion as our scale factor 1/2. This shows that the two quadrilaterals, PQRS and P prime Q prime R prime S prime, are similar figures. Example 5, quadrilateral A prime B prime C prime D prime is a dilation of quadrilateral ABCD. Find the scale factor and classify the dilation as an enlargement or a reduction. So for this here, we can just focus on one coordinate point. So from the pre-image ABCD, let's take a look at B. So B here, the coordinates of B are 0, 6. Now let's take a look at our image, A prime, B prime, C prime, D prime. Let's look at the coordinates of just B prime. We have 0, 2. So by looking at the coordinates of our pre-image and the coordinates of our image, we can find our scale factor. We want to see what we had to multiply both the x and y coordinate by in the pre-image to get to the image. So for 0, for the x coordinates, we have 0 and 0, so that's not really going to help us much. Let's look at the y coordinates. What did we have to multiply 6 by to get to 2 in the image? We had to multiply 6 by 1/3. So we had to multiply by 1/3 or divide 6 by 3 to get 2. So we know our scale factor here is 3. 1/3, our scale factor here is 1/3. Because our scale factor is between 0 and 1, we know that this dilation is a reduction. All right, last example here, we have triangle XYZ is graphed below. Draw and label the triangle X prime, Y prime, Z prime after a dilation using a scale factor of 2. So we're using a scale factor of 2 here. The rule we will follow is X comma Y arrow, 2X comma 2Y. We can first start by listing out our coordinates of the pre-image. So for X, we have -1, -1. For Y, we have -1, 2. And for Z, we have 1, 1. To find the coordinates of our image, we are going to multiply both the X and the Y coordinates by 2. So for X prime, we have -1 times 2 is -2, and -1 times 2 is also -2. For Y prime, we have -1 times 2 is -2, and 2 times 2 is 4. And for Z prime, we have 1 times 2 is 2, and 1 times 2 again is 2. We can now plot the points of our image. So we have -2, -2 for X prime, -2, 4 for Y prime, and 2, 2 for Z prime. And we can connect our points. And that's all we have.